Hello, thank you for joining me once more. This is I think I have three separate functions here that we are supposed to integrate. I'll be taking you through them one by one. I have done an introduction video explaining how to integrate a function of this form. Open my playlist Engineering Maths 1 and locate Introduction to Integration Part 1. I think it is the second or third example I spoke of. You can watch that video to equip yourself with something like this, a function raising to a power. We can also expand this function, but the power here is 5. It will take a lot of time, very cumbersome to expand this the fifth time to make it a linear function like this before you integrate. So the best option is to represent x plus 1 with a variable, x squared plus 1 with another variable. For this is a direct integration. So I'll take the first example, and then once I'm doing it, I'll explain. So for something like this, all you need, this is a constant. We would have to factorize it out, so there's no need for us to worry about it. All we need to worry about is x plus 1 raised to power 5. So anytime you come across something of this form, all you need to do is to represent what is inside the bracket x plus 1 with a variable. Let's use the variable u. So you say that let u be equal to x plus 1. Now you differentiate this u. Don't forget, though we are doing integration, we have to differentiate. So you differentiate this function with respect to x. So I'm differentiating the u dx will give us 1. So when you differentiate, the constant is 0. When you differentiate x, the result is 1. Now because you have dx here, you make dx the subject from this function. So dx is going to give us du. Why? This is over 1. So when you cross multiply here, it will be du times 1 dx times 1. So du is equal to dx, which is the same thing. So now you rewrite the main function in terms of the variables u. So we have integral of 3x plus 1 all to power 5 dx. We change it into all variables u. So I have integral of 3. Now we said x plus 1 should be equal to u. And u is raised to the power 5. And dx is the same as du. So this is dx, which is the same as du. So du. Do not bring dx here. The variable should be in terms of u only. So from here, it becomes simple for you to integrate. You can factorize this value out here. You have 3 integral of u to power 5 dot du. The dot here means multiplication. You can choose to ignore it. So now, when I integrate anything having a variable with a power, then it is you add 1 to the exponent and you divide by the result. So this is going to give us 3 multiplying the integral of this will give me u raised to the power 5 plus 1. I'm just writing this, there's no need. 5 plus 1 plus the constant of integration k. So therefore this is going to give us 3u raised to the power 6 or out of 6 plus k. This is the same as you having 3 out of 6 u6 plus k. 3 into this will give us 1. 3 into this will give us 2. So we have 1 out of 2 u6 plus k. So now in the beginning you said that let u be equal to x plus 1. Don't forget that in the beginning we said that let u be equal to x plus 1. So we substitute u back and the result becomes integral of 3 x plus 1 all power 5 dx will give us 1 out of 2 x plus 1 2 power 6 plus k, where u is x plus 1. So this is your final result. I hope that was understandable. Let me take the next example. We have here the integral of 4x cubed minus 5x plus 6. This is a direct integration, very straightforward. All you need to do is to apply integration to each part of the function. So I can choose to use, I can just use it, do one method. I can just write it in one line or break it down little by little. So let's use the integral sign to multiply through. So now this is going to give me integral of 4x raised to the power 3 minus 5. Let me put the integral sign here. Minus 5 integral of 5x plus integral of 6 dx. So everything here have to go into bracket multiplying dx. It is the same as you say, I'm just writing some steps, but there is no need. Integral of 4s cubed dx, use this to multiply through, minus integral of 5x dx plus integral of 6 dx. So now you can integrate them one by one. You have here integral of this will give you, you can bring this 4 out. For multiplying, the integral of x cubed will give you x raised to the power 4, 3 plus 1 all over 4. Then minus this one will give you 5, multiplying the integral of x, which is going to give you x 1 plus 1, which will give you 2, all divided by 2, plus integral of this. For this one, we assume that it is 6x raised to the power 0. Anything to power 0 is 1. So when I add 1 to the x to power 0, when I add 1 to the exponent 0, it will give me x. So what I am talking about is, if I have 6 or a constant, then it's the same as 6x to power 0. So when I want to integrate this, it will be 6x 0 plus 1 all divided by 0 plus 1. And the result is going to give us 6x over 1, giving us 6x. So you get it now? So now here we have 6x, then plus our constant of integration. Don't bring constant of integration here. You leave it at the last end. So therefore, this can take care of this. So I have x to power 4 minus, this cannot cancel this, so we have 5 out of 2 x squared plus 6x plus k, and this is our final solution. So you can rewrite this by saying the integral of everything here is equal to this. So let's leave it there. Then finally, let's talk about our final calculation. We have already discussed this. All you need to do is to represent whatever is inside the bracket with a variable. So we can say that let u be equal to s squared plus 1. Now you differentiate u with respect to x. So du dx is going to give us 2x. The differential of a constant is 0. The differential of this is 2 times x, 2 minus 1, which is 2x. Because we have dx here, you can make dx the subject. So dx is going to give us 1 over 2x du. So this is over 1, cross multiply. When you finish, divide through by 2x. This is what you are getting. If you don't get that, if I have du over dx giving me 2x, don't forget this is over 1. So when I cross multiply here, I am having du times 1 will give me du, which is equal to 2x times dx, giving me this. I'll divide through by 2x, divide through by 2x. This will cancel that. So I'm having dx giving me du over 2x. This is the same as 1 over 2x times du. Don't forget this is over 1. This times this will give me this. 1 times du will give me du. So that is it. So that is what we have there. Now we rewrite the function in terms of the variable u. So I have integral of x squared plus 1 all to power 4 is going to give us integral. You said x squared plus 1 should be u. So that is it. And then don't forget the u, which is x squared plus 1, has a power of 4. So we have 4 times dx. The dx here, which I didn't bring here, I forgot to do that. The dx here is the same as 1 over 2x du. So I have 1 out of 2x du. So that is it. So now you can now work on this side by factorizing 1 out of 2x outside. So I have 1 out of 2x integral of u raised to the power 4 du. So now when you integrate this one, you are getting 1 out of 2x multiplying the integral of u raised to the power 4, which is going to give us u raised to the power 5 all out of 5 plus k. You can also say 1 out of 5. So this is the same as me saying 1 out of 2x times 1 out of 5 u raised to the power 5 plus k. So now from here, I can just multiply this by saying 1 times 1 will give me 1, 2 times 5 will give me 10x u raised to the power 5 plus k. Now don't forget that in the beginning you said that let x squared plus 1 be equal to u. So therefore the integral of x squared plus 1 all to power 4 is going to give us 1 out of 10 x, then u here is what? X squared plus 1 all to the same power 5, because u here is this, but u has a power of 5 plus k. So now this is the solution for the integral of this. We are getting 1 out of 10x x squared plus 1 to power 5 plus the constant of integration, and this is your final solution. If this video has been very helpful, I would like you to subscribe to this channel if you have not. There are a lot more under integration I am going to talk about. I'll be posting these videos soon. My name is Daniel and I will be taking you through a lot of stuff. Kindly stay tuned and stay connected.